So because of we are running same field bus application layer, but we can run this on certain speeds, and we distinguish between such called conformance classes. Why does it make sense to distinguish between them? Yeah, because not each and every device needs to implement everything. So that's why we distinguish, for instance, yeah, and let's say a drive, a synchronous drive has a different real-time behavior compared to, let's say, a temperature sensor, which measures a temperature very seldomly. That's why all of them can use the same field bus application layer. All of them use the same service part with different speeds. And so we have also different requirements to the real-time of the system. That's why we distinguish between an Ethernet interface that is synchronized or that is not synchronized. The not synchronized Ethernet interfaces can be done with any standard available Ethernet controller. Nothing special needs to be done here. And in the end, we distinguish between conformance class A and B. The conformance class A is something where we do not have any control over the Ethernet interface itself, but it gives us the freedomness to use any transmission physics also, like wireless, copper cables, fiber optic cables, everything is imaginable here. Also, if we use public infrastructure, for instance, then this is all fine. This can be done here. Also via 4G, 5G, this doesn't matter. On conformance class B, becomes a little bit more. We add some services that are interesting for industry, especially for those industries where we have automation line and we want to diagnose what is about a network, what is about the connection, the neighborhood connection between two devices. Then the conformance class B is interesting because here we add topology information. That means these physical device description, how many ports do I have and who can be connected to my ports. This is something then we add also to the engineering system, and this is also something we can diagnose. On the synchronized Ethernet interface, then we are having conformance class C, which is also known as IRT network. And on IRT network, this is the only conformance class, by the way, which is bound to a certain network speed. This is bound to 100 megabit only. There's no negotiation between 10 megabit or even faster, so it has to be 100 megabit only. Nothing else is possible. And in the future, then also if the first TSN-capable Ethernet chips are on the market, then here we have, let's say, the full freedoms again from 10 to 10. That means from 10 megabit to 10 gigabit, everything is possible here. Also link speeds in between, it means 2.5 and 5 gigabit also will work. And if also then the Wi-Fi or 5G networks are possible, then also we will see wireless connections with TSN capabilities. Right now, this is under development from chip perspective. Then I think soon we will also see the first development kits running on that.